Hi, I'm Adam. Welcome back to Godot Game Lab. In this video, we'll kind of redo the battles so we have dynamic battle data and we can randomly pick between them when actually generating the map. Let me show you how it works. It's a bit less flashy than generating the whole map, but still an important feature nevertheless. So you can see that we have a new folder here in the file system called battles. And we have some new resources here. For example, I have this tier 0 bats 2 resource, which is a BattleStats resource. And you can see that I have a couple of properties I can change here, namely the tier of that battle, the weight, which is basically the chance of rolling for this kind of battle, and we have a gold reward minimum and maximum, so we can roll for a random gold amount between these two values. And last but not least, we also have a pack scene property called enemies, and this is the scene which is open here. So as the name suggests, this fight includes 2 bat enemies, and what we do is we sort of instantiate those enemies and assign the bat enemy resource to them. And this is how we can define a battle and also position the enemies on the screen. So in a similar fashion, we have another tier 0 battle called tier 0 crab, which has a bigger weight of happening. It's also a tier 0 fight. It has different gold values, and it also has a different pack scene attached to it, namely this one. And if I open this up, you can see that we only have one enemy here, which has the crab enemy resource assigned to it. So if I run the game, I get a randomly generated map like I did before. But if I click on one of these battles, the battles won't be the same anymore. You can see that I rolled for the battle with the 2 bets, and if I try to win this one and collect my battle rewards, I no longer have this constant 77 gold. Instead, I rolled for a random value between the minimum and maximum provided for that fight. So I can collect the gold, add a new card to my deck, and continue on with the next one. This one will be also a tier 0 fight. So again, I can roll for either the 2 bats or the crab enemy. I rolled for the 2 bats again, so let me win that fight as well. Again, if I collect my rewards, I have a different gold value. This time I can add cards to my deck just like I did before. And again, this will be my last tier 0 fight. So if I click on this one, you can see that this time I rolled for a different fight. So let me take some damage to show you something else we address. I have 28 health now, right? So let me kill this crab enemy, collect the rewards. You can see that it kind of offers less gold because you only fight one enemy. Let me add a new card to my deck. And if I continue onwards, this will be a tier 1 fight. So you can see that we have 2 different fights for this one, either 3 bats or a bat and the crab enemy. So if I go for this one, again, I roll the random fight between the 2 tier 1 fights I have. And you can see that my health no longer resets between fights either, because we finally addressed that issue that the battle scene wasn't using that same character stats resource we have for the whole run. So if I had 28 HP before, I will have the 28 HP going onwards. So again, I can win this fight. And if I win this fight, I'll get some more gold because tier 1 fights are more dangerous and they also provide more gold. I can add new cards just like I did before. And that goes on and on. Finally, all the battle rooms are randomized and we can pick from this whole pool of battles we have. And without further ado, let's jump into it. So let's talk the changes in terms of architecture and data first. In this episode, we'll have a bunch of data related changes, namely introducing 2 new resources and hooking them up with the different systems which are already in their place. So one of those new resources is called BattleStats, and the BattleStats resource will describe a battle. So how do we describe a battle? First of all battles will have a tier number associated with them, 0 being the easier fights at the beginning of a map or a run. Tier 1 will be all the other battles except for the boss battles, and tier 2 will describe boss battles only. Then we also have a weight associated with those battles, which basically is used for the random generation part, so we know what the chances are of actually picking or encountering that fight anywhere on the map. Then we'll also have a gold reward range because we don't really want to always give out the exact same amount of gold like we do right now. For example, 77. We want to provide a range, for example, between 50 and 100 gold, and we can roll for a random number to sort of randomize it a bit, make it a bit more interesting. And last but not least, we of course need to somehow describe the enemies which reside in that battle, right? And the other new resource we'll be using is called BattleStatsPool, which is sort of an array of BattleStats resources which we can pick from when we generate the map. And beside it being an array of BattleStats resources, we also need to provide the functionality to pick random battles based on their tier, right? Because at the lower part of the map, we want to pick random tier 0 battles. At all the other monster rooms, we want to pick random tier 1 battles. And at the very end of the run, in the boss room, we want to pick a random tier 2 battle, meaning a boss battle, right? So we have to implement these two new resources, but let's see how do they fit into the existing architecture and where we need to use them. So the first thing we need to examine is the BattleStats resource. We use that in two places, basically. One is the battle scene itself. Actually, we'll be relying on these BattleStats to instantiate the proper enemies for that battle or for that fight. Because right now we just kind of revisit the same battle over and over again. So we'll basically use the enemies property of that BattleStats resource to make the battles actually different from each other. The other place where we use this is the room resource, which is, if you remember, used for map generation, right? So the room resource will have a BattleStats property because when we generate monster or boss rooms, we don't just need to store all the data we store right now, like the position, the grid position, the type, and so on. We also need to assign a BattleStats resource to monster and boss type rooms. But if you think about it, this change sort of cascades into the project, right? Because if we change the room and we have a BattleStats assigned to it, we also need to change the map generation, right? And we also need to change the run. So changing this bit by itself won't solve our problems. We need to sort of see where we use the room and then make all the changes needed to actually hook up this BattleStats system. But it won't be that hard, I promise. What about the other one, the BattleStats pool? So the BattleStats pool is only used by the map generator itself. Why? Well, because if you think about it, we want to assign a random BattleStats resource, a random battle, to each monster type room and boss type room from the pool, right? So we'll take a bunch of stuff into consideration. Like when we generate a monster type room, we need to see if we are at the bottom part of the map or we are above the bottom part, because we need to pick a random map from tier 0 when we're at the bottom, right? But when we're not, we need to pick a battle from tier 1. And again, for the boss room, we need to pick a random battle from tier 2. So we'll be relying on this BattleStats pool resource to get those random BattleStats resources based on their tier. And that's it for the architecture. Let's see how we'll implement this in Godot. So before we jump into implementing the new stuff regarding the battles, I wanted to take a little detour because one of you in the comments suggested that sometimes I wrote self.property name when changing a property and sometimes I don't. And the question was, why is that, right? Why don't we do it consistently? Either use the self or don't. And that's a really fair question, actually. And it's an old habit of mine. See, in Godot 4, which is the version we're using, right? We have these setter and getter functions. And we mostly use the setter functions, if you remember. And we use the set keyword to sort of provide those setter functions in the project. And we always do something else besides just setting that variable. This is why we have setter functions. This is why it's useful. So we have this little node box here with the documentation open, and it says, unlike setGet in previous Godot versions, the properties setter and getter are always called, even when accessed inside the same class, with or without prefixing with self dot. This makes the behavior consistent. See, that's the thing with gamedev. It's a really cool thing that Godot evolves so quickly, but also when you've been using it for years like I am, it can be hard to override old habits, right? So in Godot 3, when you were in the same class and you wanted to make sure that the setter function will be called, you had to explicitly say self.property name to change it. And it seems like you don't really need to do this anymore in Godot 4. So I completely agree. It's just an old habit of mine, which I wasn't aware of, that you don't need to do this anymore in Godot 4. And it would make the code a lot more consistent and cleaner if we avoided this self-dot, because we no longer need it, right? So thanks for pointing that out. And we can actually make this change, right? Again, this is a refactoring and we won't gain any significant advantages. The game will behave the same way, right? There won't be any like functionality changes as a result of this refactoring. But still, if it's quick and it makes the code more consistent, why shouldn't we do it, right? So if I jump back to Godot, I have my project open, and let's go to the script tab and press Ctrl-Alt-O and open up one script. It doesn't really matter which one will open. I'll use car.gd for this, but it doesn't matter because we want to search for this self dot. So what we do is we press Ctrl-Shift-F to search or find in files, and just type in self dot and click on find. And you can see that I have 8 matches, right? And we have stats.gd, character stats.gd, and cardui.gd. And this is the exact reason why I used this self dot here. So let's click on the first one in stats.gd, and you can see that we have this take damage function here, right? And I said self.block equals clamp integer blah blah blah. Then self.health minus equals damage. And the reason why I used self dot here is because if we scroll up, we have this health property and this block property here. And both of those have a setter function, right? And when we set the health to a new value, first of all, we clamp it, and then we emit a stats changed signal whenever this value changes. So in order for this to work in Godot 3, you had to type this self dot to make sure that the setter function actually gets called because we are within the same script, within the same class. But we no longer need this. So what we can do is we can just take this self dot and remove those. Honestly, it doesn't change anything in terms of functionality, and some people might even argue that it's cleaner to leave in self dot because it sort of indicates that, hey, look out, this is going to call a setter function. It's really up to personal preference. Here, since we no longer need to do this, I really prefer the consistency. So we'll just delete it from everywhere. Okay. So I think that's all we have in stats.gd. We can save this with Ctrl-S. Okay, and if I go back to search results and refresh this, you can see that I no longer have those ones, right? So what about this one? In stats.gd, let's click on this one. And here for this create instance method, I think since we're not overriding a property but calling a method, it's kind of okay to leave self.in because what duplicate does is it creates a copy of an object, right? In this case, we're creating a copy of the resource we have. And for this one, I think it really makes the code more readable to leave self.in. So I'll just leave it as it is because I want to do this when we actually change a property, not when we call the method. So we can go back to the search results and go to character stats. Since we have an assigning operation here, we can just say mana equals max mana instead of self dot. Okay, go back to search results after saving this, refresh it, and we only have 2 more in cardui.gd. So if I click on this one, you can see that the principle is the same. I typed self.playable because in the cardui class, we have a playable property with a setter function assigned. So I did this for the same reason, but as it was pointed out, it's no longer needed. So we can just say playable equals instead of self.playable. Right, so let's save this with Ctrl-S. And if we go to search results and refresh this, we only have those 2 occurrences of self.dot, which are used for a method, not for overriding a property actually. So we can leave those as is. So that's it for the refactoring, really. And as always, I want to thank you for pointing out those little things because I believe that this makes the code a bit cleaner, personally. So these comments or observations are always welcome, right? Because together we can make this code even better than I imagined it or implemented it before. Cool. So with this little tangent over, let's move on to actually creating new stuff. Okay, so before we do anything else, we need to implement that BattleStats resource so we can change all the other systems which are depending on this resource existing. And to do so, we'll go back to 2D view, expand our custom resources folder in the file system, right click on it, create a new script, call this BattleStats.gd, make sure it's in snake case, not camel case, like I said in all of my previous videos. And make sure that it inherits not from the node class, but from the resource class. Press create and double click to open it up in the script editor. The resource itself will be a pretty easy one. First of all, we'll provide a custom class name called BattleStats. Then we'll have a bunch of export variables. We'll have one integer for the battle tier, which is the tier we were talking about in the architecture part, 0 for the easy fights, 1 for the regular fights, and 2 for the boss fights. By using the export range annotation before the variable, we can make sure that it's actually a selectable range in the inspector, which makes it easier to create it. Then we have a weight, which is a float number, and as per usual, we'll use this for the random weighted distribution implementation. When we want to randomize the different rooms, we have 2 more variables for the gold reward range. We'll have a minimum and a maximum, both are integers. And finally, we'll have a pegged scene for the enemies. And we'll come back to this later why I chose this solution to store how or which enemies we want to fight in a battle. And then what we need is another member variable called accumulated weight, so we can store the accumulated weights for each of these battle stats resources. This will be a float as well. And then the last thing we'll need is a method called roll gold reward, which returns an integer. And what we do is we generate a random integer between the gold reward minimum and gold reward maximum export variables. And that's it for the battle stats. It's pretty simple, right? So we can save this with Control S. So with the resource ready, the next thing to do is actually defining some battle stats and creating some battles, right? So let's go back to 2D view. And in our file system, we'll create a new folder in the root folder. So click on this resource folder, this root folder, create new folder, and we can call this something like battles. It makes sense to put this in a different folder so we can access it easily. And in this battles folder, we can right click this one, create a new resource this time, and we can search for battlestats.gd, which we just created, right? And we can create a bunch of fights. I won't be doing a boss fight in this video because we'll tackle the whole boss fight in its own separate video. For now, we'll create 2 tier 0 and 2 tier 1 fights. So we have a pool which we can generate those battles from. So let's call this one tier 0 bats 2, for example, and save this. And if we expand the folder, we should have a resource here. And we can repeat this process, so we'll have our resources ready. Right click, create new resource. BattleStats is fine. We can call this tier 0 crab, for example. Right click again, create a new resource. Call this tier 1 bats 3, for example. And the last one, create a new resource. This will be tier 1 bat crab or something like that. Right. So we actually need to assign values to these BattleStats resources. So double click on the first one, this tier 0 bats 2. And let's see what we need to change. We don't really need to change the battle tier, right? Because it's on tier 0, but we do need to change the weight. So let's say that this has a 2.5 weight chance of happening. And we can also change the gold reward minimum and maximum. You can use whatever values you like. I'll use something like 53 for the minimum, and for the maximum, something like 72, for example. And we also need a scene for the enemies, right? But we'll do this one by one when we're finished with setting up all the other stuff. So we can do this in batches to make it easier. So let's double click on the crab one next. And this is still battle tier 0, right? So we don't need to change this. And let's say that we have a bigger chance of actually going up against the crab at the beginning. So let's say that this has a weight of 3. For the gold reward, it can be a bit less because it's just one enemy instead of 2 bets. So something like 49 and maybe 68 or something like that. Right. We'll leave the enemies empty for now, but we'll do it in a sec. Let's see this tier 1 fight where we have 3 bets. So here we do need to change the battle tier, right? So we can just type in 1 or click on this little arrow to increment it by 1. This will have a pretty low chance of happening. So let's say it has a weight of 1. And the gold reward can be a bit bigger because you're fighting a lot more enemies now. So maybe 63 is the minimum. And the maximum can be something like 81, for example. Again, we'll create the enemies soon enough. And the last one we need to do is this bat and crab combination. So double click on this one. This is again a tier 1 fight, and it can have a bigger weight. So let's say it has double the chance, right? Compared to the 3 bets. So we'll give a weight of 2 for the gold reward. We can actually use the same if we like. So it was 63 and 81, if I remember correctly. Right. So we have all the resources set up, but we don't have the enemies defined yet. So let's see how we can do this. Well, my scene here is an empty one, so we can just create a new one. And all the parents will be node 2Ds for these pegged scenes. And we can double click and rename this to something like tier 0 bets 2, because that's the name we use for the resource. And it's pretty simple what we need to do. We need to click on this instantiate child scene button or press Ctrl+Shift+A and instantiate an enemy scene, right? And we have this enemy here now, and we can duplicate this by pressing Ctrl+D, select both of them, go into move mode by pressing W, and we can actually sort of position them however we like, right? And this one should be 2 bets, so maybe something like this. If you want to be more precise, you want them to be aligned and have the same Y value, you can go back to select mode by pressing Q. And under transform, you can see their Y coordinates. So this is 75 and this has 75. So I have really good eyes, it seems like. What do we need to do? Well, for the enemies, if you remember, we need to assign stats for them, right? And this one should have 2 bets. So if we go to our file system doc and search for bet enemy.tres, we have that enemy resource here. So we can just drag it over and do the same one for the other one. And basically that's all we need from this one. We can click on this X to sort of close that search and scroll all the way back up to our battles folder. And the reason why I opted for this solution is because it makes it pretty easier to actually position the enemies in the screen however you like, right? We could certainly did something like only assigning these enemy stats resources and maybe using X and Y coordinates and fill them out in the resource itself. So let's imagine we have an array of enemy resources here and have an array of positions, but I feel like this interactive way is a bit more like designer friendly way to do it, right? Because we can just position them however we like. It's easy to change too, like you don't have to calculate in your head with coordinates. It's a much more visual solution to the problem, but either solution is fine. I just opted for this one here. To show you how flexible is this pre-made scene system in Godot, all we need to do is save this with Ctrl+S because it's still unsaved, and the battles folder will be perfectly fine. And tier 0 bets 2 is a perfect file name, but I didn't use an underscore between the bets and the 2, so I can just delete this to make sure that they have an identical file name because it's a bit cleaner this way. And let's not forget that if we double click on this resource, this enemy spec scene is still empty. But since we actually implemented it, we can just drag and drop it here, right? And we have the 2 bets assigned to this BattleStats resource. And we kind of need to do the same for the other ones. I just speed this up in editing so we won't be wasting time with me adding enemies one by one in the same manner. So what we need to do is click on the plus sign here. Again, create a 2D scene, double click, rename this to tier 0 crab, instantiate an enemy scene, zoom in, move it however you want to. Finally, assign a stat to it, right? So this time I'll be searching for the crab enemy. Drag and drop this. Close the search. Scroll all the way up back to the battle. Save this scene. Call it tier 0 crab.tscn. That's perfectly fine. And if you double click on this tier 0 crab resource, we can drag and drop this here, right? Same process. So again, I can just speed up this whole thing for the 2 other ones. So make sure I don't waste your time with doing repetitive stuff. Okay, so with this out of the way, we have our battles ready to go, even though, again, we won't have a boss fight in this video. We'll cover it in a later video, right? But anyways, we have our battles ready to go, but we need to hook up this BattleStats resource in all the other places we discussed, right? In the battle scene and in the room resource. And sort of as a result of that, we also need to hook it up in the run scene. We need to like modify map generation and so on. So let's start hooking this up next. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. So let's change the battle first, because it's been a while since we touched that script. So press Ctrl-Alt-O and search for battle.gd. So first of all, we'll need to provide a class name for the battle now, because we'll be actually referencing it from the run script. And in order to get auto completion, it's useful to provide a class name for this script as well. On top of that, we'll need a new export variable called BattleStats, which will be, you guessed it, a BattleStats resource, so we can actually instantiate the proper enemies based on that resource. And then in the ready callback, we can finally get rid of this sort of placeholder code, because if you remember, we wanted to use the character stats from the run script, and we haven't. So what we did is whenever a battle started, we created a new instance of the character stats. That's why you didn't carry over your health, for example, from the previous fight. So now we can get rid of all this code here and actually put in some new code, because you can see that this breaks a couple of things, right? So the start battle method, which we call from here, you can see that it wants a character stats resource as a parameter. We no longer need that, so we can delete this parameter from here and from the method's signature as well. Why? Well, because if we scroll all the way up, you can see that we have a character stats export variable, which means we can set this from the outside world, right? And we'll do so in the run scene, because the run has the current character stats. So we no longer need to create a new one, a temporary one, and pass it around. We'll just sort of override this from the run to make sure that it shares the same resource as we currently have in our run. So we can delete this one. We can also delete this initialized carpile UI call here and put it, I'm just cutting it with Ctrl-X and paste it in the start battle function. So we also need to change this start battle method, because if you take a look at it, we have some errors, right? So what we do here first is we change that stats keyword to character stats, because if we scroll all the way up, you can see that that's the name of our export variable, which will hold the character stats we currently have for our run. After changing that, we also need a bunch of new things. For example, we can set the battle UI's character stats property to the character stats we currently have, do the same for the player, and finally, we call the enemy handler's setup enemies function, which has our BattleStats resource as a parameter. Mind you that this is a new function which we haven't implemented yet, and this will be responsible for taking that enemy packed scene we have defined for each battle and actually instantiating those enemies in that current battle scene. So we have this setup enemies method, which takes in the BattleStats resource as a parameter. How do we set up the enemies? What do we need to do? First of all, we'll have a safety check to make sure that we actually have a valid BattleStats resource, because if we don't, then we don't really need to do anything, right? We don't have enemies to spawn, so we can return from the function immediately. Then what we do is we need to make sure that if we do have enemies spawned by default, we actually need to delete them with Q3, because we'll have new ones, right? From the pegged scene in the BattleStats resource. So after deleting all the current enemies or the previous ones or the placeholder ones, we can actually instantiate that pegged scene by calling BattleStats.enemies, which property refers to the peg scene itself, and calling the instantiate method. We can store that instance in a new variable called allNewEnemies. And what we can do with that instance is we can iterate through all of its children, and if you remember, all of its children will be enemies, right? Because that's how we set up that scene. We had a root node, a node 2D, and all of its children are actually enemies. So what we do is we take that actual enemy we have, we duplicate it and cast it to an enemy with the as keyword and add it as a child to ourselves, the enemy handler, right? And after we're done with all of the enemies we have in that packed scene, we no longer need that packed scene. So we can delete it, right? Because we duplicated all of the enemies present in it in that for loop. So we can just kind of get rid of the temporary instantiated scene and we're good to go. So that's all we need to do in the enemy handler, and we can save this with Control S. So before we actually move on to changing the whole map generation thing, the rooms and all that stuff, it would be nice to test this if it works or not, right? So the final thing we need to do is to change the run itself to test if this new battle changes work or not. So press Ctrl+O and search for run.gd. And if you take a look at the on-map exited callback all the way at the bottom, what happens is when we click on a monster type of room or a boss type of room, we change to the battle scene, right? So what does this do? If we take a look at the change view method itself, what it does is it instantiates a new battle scene, so far so good, and then adds it as a child to the current view node. And that will no longer do it. Why? Well, because in battle.gd, we just changed the whole thing, and we said that we need to set both of these variables, the character stats and the battle stats, from the outside, right? The battle is no longer responsible for instantiating any temporary resources or things like that. So we actually have to do this somewhere else. And we have to do this in the run, right? Because that's when we change the view. So just simply calling the change view with the battle scene passed on as a parameter will no longer be enough to provide this functionality. So we can create a new callback method and name it something like onBattleRoomEntered. And we'll have access to the room data. And what we do is we call the change view method just like we did before, because yeah, we actually have to change the view to the battle scene. But what we do is we store that reference to the battle scene, which we get back from the change view method, cast it to a battle and store it in a variable. So we can do stuff to it after changing the view. What stuff do we need to do it after changing it? Well, we need to set the character stats property, that export variable, to the character we currently have. And we also need to assign a battle stats to it. And you can see that we sort of have the room as a parameter. So we can get this data from the room later on, but we haven't implemented that change yet. So what I do for now, temporarily, is that I preload one of those we created, right, from the battles folder. In this case, for example, the tier 0 fight with one crab only. And then we can call the start battle method of that battle scene to actually kick things off, right? But just by providing this callback method, we're still not done because we are not calling this callback method. So if we go back down to this onMap exited one, where we assign what we do based on the room type, we need to change this as well. And what we do is, instead of simply saying change view to the battle scene, we can sort of override this and call this new callback we have, this onBattleRoomEntered. And we pass on the room as well, which we'll use later, right? Because right now we are just using a placeholder tier 0 fight for every battle room. And we sort of need to do the same for the boss room, because it's considered a special kind of battle room, right? And these are all the changes we need to test this. So what we do is we save this with Control S. Again, we change these two callbacks here, and we added a new callback method to make sure that we don't just change the view to that battle scene, but we actually inject the dependencies to those export variables we wanted to. Right, so to test this, press Ctrl+Shift+O and search for run.tscn. And if we run the scene with F6 or by clicking on this button, so when we run the game, everything seems fine and looks like it's working perfectly. But when I try to go into battle, I get an error message, which is super weird, and it took me a while to debug, and it's a head scratcher one, and that's often the case with game dev. So I figured instead of editing it out, I just want to show you how you can deal with these things. Right, so we have an error message called cannot call method duplicate on null value. Right, why do we have this? Well, because in the player handler script, when we start a battle, we want to duplicate the character's deck and create the draw pile from it. So how is it that it's a null value, the character's deck, right? Because we set it up in the warrior resource. If I double click on it, we have the starting deck here. So when we create an instance, it should be duplicated. And let me tell you that it is duplicated. We're doing something else wrong. So what we do is in battle.gd, we made all these changes, right? And I wasn't careful enough with those changes, because What we do is in the ready callback, we call this start battle method, but we don't have to anymore, right? Because when we take a look at this run script, what we need to do is we need to call this from here, right? Why? What's the difference of calling it in the ready and calling it in this place in the runs thing? Well, it's pretty simple actually if you can wrap your head around it. What we need to do is with the change view method, right? We create a new instance of that battle scene and add it to the scene tree as a child of that current view node. So when we do this, the ready callback gets called because the node is ready when we add it to the scene tree. But the problem is the ready is called earlier than actually setting those export variable dependencies we have. So this is what we want to do instead. We want to actually instantiate that battle scene, enter it into the scene tree, whatever. It stays there, right? But I want to be the one to determine when we actually start the battle. And this is why we call the start battle method here, only after actually assigning those export variable dependencies. So here, by leaving this one line of code here in the ready callback in the battle.gd script, what we do is we call this twice, or we try to call this twice, but the program runs into an error before we can call it twice. Because this call will happen way before this one, because in the change view method, we instantiate that battle scene and it gets ready. And because it's ready sooner than actually assigning those variables, calling this start battle method will result in a runtime error because that character stats will be null. So what we can do about it is pretty simple. We actually need to delete this from the ready callback, right? We don't want to start the battle whenever that battle node is ready in the scene tree. We only want to start it manually when we call this method. So by deleting this one line of code here, which I recklessly left in there, we can rerun the game. And now if I click on one of these battles, I should be greeted with one crab. Okay, so everything works perfectly. It was a silly mistake on my end, right? I just wanted to show you this. Cool. So now we can move on to actually updating the map generation and the room and things like that. So the next thing to update is the room itself, which will be a pretty simple change. So press Ctrl-Alt-O and search for room.gd. And here what we need to do is actually just having a new export variable. I also included a comment here to indicate that this is only used by the monster and the boss room types, but those rooms, those type of rooms need to have a BattleStats resource, so we can just sort of declare an export variable for the BattleStats resource. And that's all, pretty simple, right? So we can save this with Ctrl-S, but changing the room itself doesn't do anything. We actually need to change the whole map generation and map things in order for this to work. And just before we can actually change the map generation and the whole thing, we need that other resource called BattleStatsPool. Why? Well, because we need to be able to pick a room randomly based on the tier it has. And we also need to have a pool or a collection of BattleStats resources to know which battles we can choose from. And the easiest way to do this is to create a new resource for this. So let's go back to 2D view and expand our custom resources folder, right click on it, create a new script, call this BattleStatsPool.gd, and make sure it inherits from the resource class, not from the node class. Press create and double click to open it up in the editor. And this script will be a resource, but it actually has kind of a lot of functionality attached to it, as you'll see in a second. So why don't we start with a custom class name called BattleStatsPool. Then we'll actually only have one export variable called pool, which will be an array of battle stats, basically all of them. Then we'll have an array of floats, which I called total weights by tier, right? Because we actually want to pick randomly between the different tiers, right? So they are kind of separated from each other. So we have to calculate the total weights for each tier on their own. And as sort of like a complementary function or method for this, which is really useful, is to get a tier as an integer parameter and filter through the whole pool and return a new array of BattleStats resources which only contain those battles with tier 0 or 1 or 2. So what we do is we take the pool array and call the filter method on it, and we'll provide an anonymous function. And the basis of the filtering will be that the BattleStats resources battle tier is equal to the tier we have in the parameter, right? And after filtering those array elements, we can return the new array. Then we'll also have another supportive function, which is for setting up the total weights for each tier, or a specific tier in this case, again, passed in as a parameter. So what we do is we first of all need to get all the battles for that specific tier with the function we just provided earlier, and reset the total weights by tier arrays element according to that tier to 0, because we sort of want to recalculate it whenever this method is called. And we do two things basically. It's pretty similar to what we did with the enemy actions back in the day. Random weighted distribution, setting up the weights. You should be familiar with this by now. So we iterate through all the battle stats for that specific tier, and we'll increment the total weight for that tier by the current battle's weight, and also set that current battle's accumulated weight and store it based on the value we currently have. If you remember, in the BattleStats resource, we had a member variable called accumulated weight to make sure that we can store this per battle. Right, so for this method, that's all. Then, sort of a more important function, and one we'll be relying on in the map and the map generation classes, is this getRandomBattleForTier method. And what this does, it gets a tier as a parameter and returns one random BattleStats resource from that specific tier. And here we use the sort of familiar random weighted distribution rolling method we used a bunch of times already throughout this whole project. So what we do is we roll a random number between 0 and the total weights for that tier we just set up with the previous method. Then we grab a reference to the array of all the available battles for this tier, iterate through all the battles we have, and see if the roll matches any of those accumulated weight values, and if so, we can return that battle from the function. And if for any reason this whole thing goes wrong, then we can return null, saying that we haven't found anything, but this should never occur, right? And then finally, we have a setup method, which we can call once, just to make sure that when we get starting with the room generation in the map generation class, all of those tiers are already set up with their weights. So what we do is we basically create a for loop for tier 0, 1, and 2, and call that setup weight tier method with that I variable we currently have in the for loop. Pretty simple, right? But we do have some functionality, because it's kind of the BattleStatsPool's responsibility to be able to get a random value from this. We could certainly do this in the map generation, but sort of abstracting this out makes both of those classes easier to understand, and the map generation is pretty long on its own already. So I think it's certainly a good idea to do this in this separate way, and it's only like 40 lines of code, so I hope that it's not too bad or not too difficult. Right, so let's save this with Control S. And let's not forget that we actually need to create this pool resource, because just by defining it, we still have no resource in the file system. So let's go back to 2D view. And I think we can put this under the battles folder. So let's expand the battles folder, and we have all the BattleStats resources with the enemy scenes here. And we can right click on this, create a new resource, and BattleStatsPool is what we want here. And we can call this BattleStatsPool in snake case. Double click on this, and all we need to do is to provide an array of BattleStats resources. The rest is handled by the methods themselves, so we can use a size of 4 for now, but you can always expand it when you add new possible battles to your game. But right now what we need to do is we actually drag this in one by one, but make sure you don't use the tscn files, you have to use the tres files, right? Okay, so that's good to go. We can save this with Control S, and now we can actually start changing up the map generation system to make the battles more interesting and random. Right, so the first logical place to start adopting to all these changes is the map generator itself. So let's go to the scripting tab, press Ctrl-Alt-O, and search for MapGenerator.gd. And the first thing we need here is actually access to this BattleStats pool we just created, so we can get the random rooms whenever we want to. So we can define a custom export variable here called BattleStatsPool, which will be, no surprise, a BattleStatsPool resource. So that's one thing. Then in the generate map method, when we actually start assigning this boss room and set up the random room weights and set up the room times, before we do all that stuff, we actually need to set up the BattleStatsPool itself to make sure that the accumulated weights and the total weights are calculated and set up and ready to go. So we can call BattleStatsPool.setup here. Then we actually need to make 3 changes, one for the boss room, one for the tier 0 fights at the very beginning, and one for all the other random rooms we can have. So let's start with the boss room. Go to the setup boss room method, and you can see that at the end of this method, we assign the boss room's type to be room.type.boss. And what we also need to do is we can say that this boss room's battle stats should be equal to a random tier 2 battle stats resource, right? And we can sort of query this BattleStatsPool resource and call this get random battle for tier 2, right? In this case, this will result nothing because we don't have a boss room yet, but again, later on we'll have a boss room, all right? The functionality is there. So if you want to provide a boss battle already, you can do so, right? Just by creating a tier 2 battle and assigning it to this BattleStatsPool resource. Right, so that's 1 out of the 3. The next one will be the first fights, which are guaranteed to be battles, right? And we do this in the setup room types method. So if we go to the setup room types method, you can see that this one here says the first floor is always a battle, right? But it's not enough to say that it's a monster type of room anymore. What we also need to do is, you guessed it, set the battle stats resource to random battle, but this time from tier 0, right? And you can see that we don't really have to do this with the treasure and the campfire rooms, but we have this one here. The rest of the rooms are assigned randomly. How? Well, we call this set room randomly method, right? So if we go to this method and scroll all the way down, you can see that at the end of this algorithm, we set the room type to a type candidate, which we just rolled for, which sort of adheres to all the rules we have here. And then what we can do after setting the room type to the final candidate, we can check if it's a monster room or not, right? Because if it's a monster room, we actually have to grab a battle stats as well. And what we can do is we can say that the tier for this monster room will be 0. But if the row index is actually greater than 2, meaning that we are at least on floor 4, then we override this and say that the tier for this monster room should be 1 because we are no longer in one of those first 3 floors. And then either way, it doesn't matter if we are at tier 0 or tier 1, what we do is we override the room to sets BattleStats resource, and again we can query the BattleStatsPool and get a random battle for that tier we have, which is either 0 or 1. Here for this part of the code, I could have used the ternary operator, which does exist in GDScript and Python similarly, but I just don't like it. I think it's not really easily readable like in C or C++. So instead, I've sacrificed a couple lines of code for readability here because using a ternary operator would result in 1 line of code, which does the same thing, but I think it's more readable this way in GDScript at least. But anyways, that's all we need to do, right? For the boss room, we generate a tier 2 battle stats. For all the first floors, when we start the game, we generate a tier 0 battle stats. And for all the other ones, we decide based on the row index, and we either get a tier 0 battle stats resource or a tier 1. Anyways, that's all we need from the map generator side. So we can save this with Ctrl S. And we're basically almost done. We just need to change a couple of final things in the run script. But before we do that, if we go all the way up to the top of the script, let's not forget that we have a new export variable which we haven't set in the editor yet, right? So let's go back to 2D view, and in the run scene, and I have the run scene open and we have the map here. So you can just click on this icon to open the scene in the editor, but if you don't have the run open, what you can alternatively do is press Ctrl-Shift-O and search for map.tscn. Because in the map scene, we have our map generator node here, and you can see that this BattleStatsPool resource is empty. And that's not good because we want it to have access to all the BattleStats resources we have. So we can click on this one, press quick load, and it should appear here, right? battle/BattleStatsPool.trs, perfect. So we can load this, and this is very important to not miss this step. And we can save the map scene by pressing Ctrl S. And let's see what we need to change in the run script finally. So let's go back to run and change to the script tab. We need to make 2 tiny changes and we're done. One of those is actually this one. We have this new callback method called onBattleRoomEntered, And if you remember, we sort of just preloaded like arbitrarily one of those BattleStats resources, the tier 0 crap here. But we no longer need to do this because the room resource actually has an assigned random room to it if it's a monster or a boss type of room, because we provided this functionality when we generate the map. So what we can do instead is just say room.battlestats. And you can see that I don't have auto completion for this one, and this sometimes happens in Godot. But if I go to the room.gd script, I do have a property called BattleStats. If this annoys you and you want your auto completion to be updated, I found that actually going to project and reload current project will update it. So if I were to reload this project, I would have this BattleStats offered as an auto completion here, right? So this is one thing we need to change to make sure it's random. And another one is actually winning the battle. So if we can scroll down a bit, you'll see that we have this onBattle1 callback, which changes the view to the battle reward scene and assigns a bunch of variables. But you can see that we have a comment here saying that this is temporary code. It will come from real battle encounter data as a dependency, right? And this is concerning the gold reward, which is like constant 77 here. So we can delete the comments for sure. The question is, how do we access the room here? Because we don't have the room passed on as a parameter to this battle1 callback. Well, if you remember, we do have access to our map, right? So we can do something like map. And in the map, we do have a property called last room, where we store the last room we visited. So we can do map.lastRoom, and that room, because it was a monster room, it does have a BattleStats resource. Again, I don't have auto completion here, but we do have a BattleStats resource for room.gd. And what we can do is, if you remember, let me go to this room.gd here. See, we have the BattleStats resource. And we know for sure that if I'm at a battle reward screen, the last room I visited was a battle. So that BattleStats script, that resource itself, if you remember, we have one method called rollGoldReward, right? And it will roll a random integer between the minimum and maximum values assigned to that room. And that's perfect, because that's what we want here. We want to have a randomized gold reward, and the BattleStats has the functionality to provide this to us. So if we go back to run.gd, we can call this rollGoldReward method. And this whole expression will return an integer value for that specific room between the minimum and maximum values, right? And that will make our reward a bit more dynamic, so we won't always just get 77 gold. Cool. Basically, that's it. We're done with all the changes we need, so let's test if it works or not, right? So let's save this with Control-S and run this run scene with this button here, or F6. And if we start a new run, we can see that the map is still generated perfectly fine. And I can click on this one here. And see, this time I rolled for this 2 bats battle instead of the tier 0 crab battle. So let me try to win this one. And if we win, we have the battle reward scene. And you can see that I get 65 gold. So it's no longer just this constant 77. I can collect my rewards here and continue on. I have 135 gold, and if I click on the next battle, again, I rolled for the 2 bats instead of the 1 crab. Let me try to win that battle. And one thing you might notice is that I have 24 HP now, right? So if I win this battle, I have 69 gold now. Cool, add it to my gold. Yeah, I can skip this reward. And if I continue down this path, again, I rolled for the 2 bats. But you can see that my HP no longer resets at every fight. I no longer create new characters for every fight. I use the same one, which is shared in the whole run. And if I win that battle too, I get a random amount of gold. I can add new cards. And this fight should be different from the previous ones, right? Because I completed 3 floors. And the 4th floor should be a tier 1 fight. And that means either 3 bats or 1 crab and the bat, and indeed it is, right? So if I win this fight too, I'll get more gold because the gold range is a bit bigger. I can get new cards and continue down the path. See, I rolled again for the bat and the crab fight. Cool, so everything's working perfectly fine. And I guess that's it for this video. And I'll see you in the next one. Bye-bye.